So today we're going to be looking at the average atomic mass, and to do that we will use the M&Mium lab. So let's get going. Okay, so let's take a look at the procedure, and you will also need either a copy of the lab that you've printed out from Schoology, or you'll need to copy down this data table. Okay, so we're going to do the M&Mium lab, the average atomic mass, and what we're going to use as a sample is we're going to use the sample of M&Ms, and so here's our sample of M&Ms. All right, and if you can tell, there's a mixture of two different types of isotopes in there. There are the small m M&Ms, and then there are some larger M&Ms, and those are our two different isotopes, small and large. So the first thing we need to do is we need to first separate those out into two different bins, and so that's what we're going to do right here. We're going to separate those out into two different bins. Okay, I've separated the two isotopes into the two different bins. In this bin we have the small ones, in this bin we have the larger ones. Now I need to count them. After counting, I've determined that we have 104 of isotope A and 30 of isotope B. Now we're going to determine the mass of that collection of isotopes. You can see the balance is already zeroed. I'll put the weighboat on there. Hit 0. These are isotope A. Now we're going to do isotope B. Okay, so copy down your data here on the data table. Make sure you have everything you need, and let's then start processing the data. Okay, so now our data processing, we need to determine the average isotope mass. So you're going to take the total mass of isotope A, divide that by the total number of isotope A atoms. That'll be the average isotope A mass. Then you take the total mass of isotope B, divide that by the number of isotope B atoms, and that will be the average mass for isotope B. After that, you will have to determine the relative abundance. So you have to find out the number of all of the isotopes, A and B together, okay? So to determine the relative abundance, you would take the number of isotope A divided by the total number times 100. That would be the percent abundance of A. To determine the percent abundance of B, you would take the number of isotope B and divide that by the total number of all of the isotopes, and that would be times 100. That would be percent of isotope B. Now you need to figure out the average atomic mass. To do that, you're going to take the two isotopes, their masses, and you're going to use the average masses. You're going to take the masses and the percent abundance. So isotope A mass of the average mass of one atom of isotope A times the percent abundance plus isotope B mass, the average mass of isotope B, times percent abundance of isotope B. Add those two products together, and that will be the average atomic mass for M&Mium.